So I made this duodecimal clock in JavaScript, and I'm going to show you the concept behind it, the base system, what does duodecimal mean, base 12, and how did I make it in JavaScript. So I'll show you that here. So here's the clock, and there's the link to it if you want to go check it out. And a base is just a way of representing numbers. So a base B is made up of digits where they're from 0 to b minus 1. So what does this mean? Base 2 is made up of 0 and 1, which is binary. Base 8 is made up of 0 to 7. Base 10, which is decimal, which we use, is 0 to 9. And then for anything that's greater than 10, we just use, we start using letters. I don't know what happens once we get past, 26 letters. I don't know what we start using, but to convert it back, we will just use this equation. So we have a base where we have each digit A. Each digit A, you just take that and multiply it by, for base 10, that's the tens place, or ones place, tens place, hundredths place, which I can show you here. So 205, 2 times the hundredths place, plus 0 times the tens place, plus 5 times the ones place, get us 205. Similarly, for binary, instead of a ones, tens, and hundredths place, we use 2 to the 0, 2 to the 1, and 2 to the second. So that's 1 times 4 plus 0 times 2 plus 1 times 1, which gives you 5. Similarly, for base 16, 3e, keep in mind e is 14, I think, 13 or 14. Anyway, 3 times 16 plus e times 16 to the 1 gives us 62. And there's something we can note here that's kind of cool. It's 10 in any base, 1, 0, is equal to that base. So in base 2, 1, 0 is 2. In base 10, 1, 0 is 10, obviously. In base 16, 1, 0 is 16. And there's a quick proof right there. Pretty simple to understand. And so you can pause the video, take some time to do that. That's just a quick example if you want to try it out. So I wanted to use this concept of a different base system for making a clock. Clocks are either 12-hour or 24-hour, so I decided to do base 12, which is kind of cool. So the set is from 0 to b, where a is 10, b is 11. And then the hours go from, normally they go from 0 to 23 if you're doing base 10. But in base 12, they go from 0 to 1b, where 1b is 23. And what's cool about these is that in base 12, you have 2 digits. The first digit will be A1, and that is going to tell you whether it's AM or PM. And then the second digit is going to tell you the actual 12-hour time. So we can see, at 03 in base 12, the 0 tells me it's AM, the 3 tells me it's 3 AM. So in this case, 13 is 3 PM. 1A is the A is 11, and the 1 tells me it's PM. So in a sense, this is both a 24-hour and a 12-hour clock in one, because there's no separation of AM and PM. That is an inherent property of the first digit. Thank you for making it this far through the video. If you like this so far, and if you like math and computer science content, please consider liking and subscribing, and continue on with the video. And so now I'll kind of go into how I did this in JavaScript. So I used what's called a interval simulation loop, where I update the time and then I update the clock. So I take the time for every minute, hour, and second, and then I convert that from base 10 to base 12, and then I update the clock. So pretty simple when you actually get into it. And then JavaScript, I put this as a note, JavaScript is a very handy feature called setInterval, which allows you to call a function, in this case 100, every 100 milliseconds. And then I made this function called base 10 to 12, which just converts something from base 10 to base 12. Pretty simple. You just take the floor of the logarithm of log base 12 of the number, and then you take that number and you put 12 to that number, and then you divide your current number you're trying to change by that, and take the floor, and that becomes your leftmost digit. And then you set your number equal to the remainder of that, and then you subtract your exponent from 1 and repeat this. So I'll show you here. Easier to understand with an example. Let's say we're trying to convert 7 from base 10 to base 12. You take the logarithm that gives you 0. 12 to the 0 gives you 1. 12 to the 1 gives you 12. So it's 0. And then you divide, and of course that's 7 divided by 1, which is 7. And that becomes your digits. So 7 in base 10 becomes 7 in base 12. For a more complicated example, we could take 13 in base 10. What does that become in base 12? Well, we can do the logarithm. That gives us 1. And then we divide that. 13 goes into 12 one time. Pretty simple. That becomes our first digit, 1. And then our number becomes the remainder, because 13 minus 12 is 1. And then you do the logarithm of base 12 of 1. 12 to the 0 equals 1. And then you divide that. 1 divided by 1 is 1, becomes our second digit. So 13 to the 10 becomes 11 base 12. You just simply do that, and then you update each of these individual parameters. They're actually strings. So you do what's called concatenation, where I just concatenate both digits. So I do 1 and 9 as text, and then that's this. So this would be, right now it's 9 p.m. and that tells me it's the PM part. And this would be 46 here, which is a times 1, which is a is 11 or 10, and then so that would be 3 times 16 plus 10, which is 46. And then this is constantly counting up as seconds here. And that's how I did it.